I'm going to discuss about some important topics in computer science, and the topics are user mode, kernel mode, system call, compiler, interpreter, and JVM. And the first one is user mode. Before going to user mode, you have to well aware about dual mode. Dual mode refers to a system that operates into two distinct modes, typically to ensure security and stability. That means whenever you want to switch, you can switch from user mode to kernel mode and vice versa. And what is meant by user mode? Uh, User mode means the program which runs in user mode, meaning it does not have any direct access to hardware or files. For example, if you request to open a file, that means in C program you use the method ifstream file, etc. Is executed. The program requested the OS to open the file through a system call, and the operating system which is running in kernel mode verifies the request, checks permissions, and provide controlled access. If the file is missing or permission is denied, the operating system unauthorized access and returns an error. Here you will see whenever you want any hardware requirement and anything others, you can switch from user mode to kernel mode. Whenever your operations are over, then you can come back to the user mode. Next one is kernel mode. It is somewhat quite opposite to the user mode. It has full access to the hardware. That means we can execute privileged instructions like modifying memory addresses, handling interrupts, and managing system calls. If a process crashes in kernel mode, it may cause a system-wide crash. Here you will see a dual mode. In dual mode, there is two components as kernel mode and user mode. Whenever the user wants some changing in hardware, that means RAM, memory, or access any main memories components, that then it uses a function. That function is called system call. What is meant by system call? We will read about further slides. And when you switch to the kernel mode, that means operating system core part, and in this operation, whenever your operations have done or all these are stuff have over, then you can switch again from kernel mode to user mode. There is switching from kernel mode to user mode and user mode to that calls context switching. And the next one is system call. We already discussed about why we use the system calls. Whenever the user want to access the kernel part, then it can't directly access, so it uses a function methods. That methods are named as system calls here only. That means here system call is the interface between a program and the operating system. It allows applications in user mode to request services from the kernel. Here some of the system calls are read or write. These are file to read the file, to write the file, etc. Fork to create a child class. Ex is exec, running new programs. Open, close functions also to handle the files, etc. These are the some overview about system call. And the next one is compiler. Here compiler means it converts high level source code to machine code. Here high level language means C, C++, Java, Python, etc. to machine code. That means what? Machine understandable code. That is binary language obviously. So it performs some of the operations to compile that code. That means like skill analysis. That means tokening that source code, syntax and semantic, correcting the all the syntax and structure, grammar of the code. Code optimization. That means improving its performance, and code generation, creating machine code. Interpreter. It is somewhat similar to compiler, but the main difference of compiler and interpreter is interpreter executes source code line by line instead of converting into machine code at once, whereas in compiler it executes an entire code at once. Slower than a compiler, but useful for scripting language. Whenever you get error at the last line, it's okay. But whenever you get the error at first line, it stops that. It can't execute to further code. Some of the examples of interpreter are Python, JavaScript, and Ruby. And the last one is JVM. JVM stands for Java Virtual Machine. Uh, it is an abstract computing machine that enables a computer to run Java programs. It provides a runtime environment that translates Java bytecode into machine-specific code. Here there is a Java Development Kit JDK. It is a software development kit used to develop Java applications. It includes all the tools required to write, compile, debug, and run Java programs. In JDK, there are some components like Java compiler, runtime environment JRE, and Java virtual machines JVM. Here, what is meant by JRE means provides everything needed to run the Java applications, includes JVM, core libraries, and supporting files, etc. Here, JVM means converts bytecode into machine code for execution, performs memory management, security checks, and garbage collection. It is somewhat overview about Java virtual machines. The main aim is used to convert bytecode into Java bytecode into machine code for execution. Thank you.